Hello chicos, today we're gonna do lesson 2. It's a big review on angles, polygons, triangles, and quadrilaterals. So be ready to review a lot of this theory that we have learned before. Okay, the first thing is about lines. Remember that if two lines touch each other, they're called intersecting lines. If they don't touch each other, they are called parallel lines. Remember, parallel lines have the same direction. And that is why they never touch, because they're going in the same direction, they never touch. And then we have these other kind of lines, which they are intersecting. Notice that they touch in one point here, in the center, but they form 90-degree angles. These are called perpendicular. Perpendicular lines, like we've learned before, form 90-degree angles in the area where they intersect. After that, we also have angles. You guys have learned angles before. The acute angles look like these. The measurement is less than 90. Right angles look like an L. We usually put it with a square, and they are 90 degrees. Obtuse angles look like this. They are bigger than 90, and they measure more than 90, but less than 180. The straight angle looks like a straight line, but we usually have a point in the center to indicate that's the vertex, and we have a 180. That's the measurement. Now remember that angles are not distances, but they're more like opening. And they are formed by a vertex, which is the point that is here for all of them. And then they're also formed by two rays. Rays, remember that they are half of a line that start in one point and keep going forever. So that is an angle. It's an opening. We have an initial side and also a terminal side. The next section is polygons. Remember that poly means many and gons means angles, but they have three very specific characteristics. They are simple, they are closed, and they have straight sides. So before we look at the polygons and we remember their names, let's look at examples that are not polygons. For example, these three shapes. Why are these not polygons? The first one is not closed because it doesn't start and end in the same point, so it's not closed. The one in the middle has a curve, and because of that, it's not a polygon. And the last one, as you can see, it's like two triangles making the shape. That is not simple. So whenever we have two shapes making the shape, is not simple. So those are examples of not polygons. Now let's go to the next page and remember the different names for the polygons. Remember that we give the name according to the number of sides. There are no polygons of 1 or 2 sides. The smallest is 3, and the name is triangle. 4 is not square. Square is a kind of quadrilateral. 5 is a pentagon. 6 is a hexagon. 7 is a heptagon. 8 is an octagon. 9 is a nonagon. 10 is a decagon, 11 is endecagon, and 12 is a dodecagon. After that, we usually just say 13 gon, 15 gon, 20 gon, just the number of sides with the word gon at the end. Now we have something that is called regular polygons. What are regular polygons? Do you remember? Regular polygons have two characteristics. They are equiangular, as you can see on the word. Equi means equal, so it's equal angles, and here is equal sides. Okay, now let's do a little drawing to see when a polygon can be equiangular but not equilateral. For example, a rectangle. The rectangle has all equal angles, but notice that it does not have all equal sides. And an equilateral, for example, is a rhombus. The rhombus has all equal sides, they're all the same, but the angles are different. Now, if we combine the two characteristics, we get a regular polygon, which means again that it is both equiangular and equilateral. And in this case, the example would be a square. It's equiangular, which means all the angles are the same, and equilateral, which means that all the sides are the same. We can also think about all the polygons that have the same kind of characteristics. They can be equiangular, but not equilateral, or equilateral and not equiangular. But if both of them are together, then they are classified as regular polygons. The next section is about triangles. And remember that triangles can be classified by the angles or by the sides. The first one here, by the angle, we see that there is a right angle. So the triangle is right triangle. The right triangle has one right angle. Then we have this one that has all acute. So that would be an acute triangle. And again, an acute triangle has all three angles less than 90. And then finally, we have the obtuse triangle. And again, the obtuse triangle has one obtuse angle. Now notice that both the right triangle and the obtuse triangle have two acute angles, but those are just because that's what is left. Remember that the sum of the angles in a triangle is always 180. So if we already have 90 or an obtuse triangle greater than 90, then the other two have to be acute. We can never have two right angles in a triangle or two obtuse angles in a triangle. It's always a right angle with two acute angles or an obtuse angle with two acute angles. Here in this section, we also have something that is called the equiangular. And again, equiangular just means that all of the angles are the same. Now, it just happens to be the same as an equilateral because in a triangle, the equiangular is also always equilateral, which is the one that we know more. We usually call these equilateral. Then if we go back to the first one, when we have two equal sides, that's called isosceles. And then if we have three different sides, it's called scalene. And again, the equilateral, which has three equal sides and angles. So in this case, this is the example for a regular triangle. A regular triangle is also known as an equilateral triangle. Let's look at these examples. In example 2.1, we have to find x. Now we have to remember that the sum of the three angles is 180. So in this case, we already have 130 and 30. So to find x, we have to subtract 180 minus 160. And the answer for x equals 20 degrees. For example 2.2, we have to also find x and y, but they're giving us an extra information. They are saying, with these two lines, they're saying that it's an isosceles triangle. And an isosceles triangle has two equal sides, but also two equal angles. X and 50, the ones opposite to the equal sides, are the same. So I can just say that x equals 50. Now, using the same information that the sum is 180, I'm going to subtract 180 minus 100, because 50 plus 50 is 100, to find what is y. And y is 80 degrees. Finally, in example 2.3, to find x and y, they're also telling us in another way that this is an isosceles triangle. How? Well, by saying that these two sides are 8. Since they're both 8, now we know that this triangle is isosceles. And in the same way that we saw in example 2.2, these two angles are going to be the same. Now they're both unknown, but we can find them because we know that 180 minus 110 is going to equal x plus y. Now x plus y is the same, so I can actually just divide by 2. So this is going to be 70 divided by 2 equals x and equals y, which is 35. Okay, let's go to the next page, in which we're going to review quadrilaterals. Remember that we talked about how quadrilaterals have 4 sides. So we're going to learn about 2 kinds of quadrilaterals, which are parallelograms and trapezoids. Remember that parallelograms have 2 pairs of parallel sides, and trapezoids have only 1 pair of parallel sides. The most common parallelogram looks like this. Notice that if you look for the pairs of parallel sides, this one is parallel with this one, and this one is parallel with that one. They go the same direction and they never touch. If we're going to draw a trapezoid, the trapezoid has 1 set of parallel sides that never touch, but then the other one is going to touch if we extend the sides. So in this case, only this pair of parallel sides exist in a trapezoid. Now in a parallelogram, we have equilaterals and equiangulars, like we talked before. So we can have rectangles that are a parallelogram with 90-degree angles, and rhombus, which are a parallelogram with all equal sides, or equiangular. Now, if again we bring them together, we have the square, which is a parallelogram that is both a rectangle and a rhombus. And this is the review on quadrilaterals. So go do your practice, and we'll see you in the next video.